next problem or group of problems, let's take a look at the same idea. So they look a little bit different, but they're the same. We have negative 5 to the 7th power times negative 5 to the 6th power. Now, we have these negative 5s. Those are our bases. So this is the first time that we're actually seeing numbers as our bases instead of our x's. Again, remember this is big because we're not used to doing this. The base stays the same, even if it's a number. If we're dealing with exponents, the base always stays the same. So the negative 5 and negative 5 are actually going to just still be negative 5. They'll keep their parentheses. And remember, when we're multiplying, we do what to the exponents? We're going to add them up. Well, let's see what's going to happen here. The 7 and 6 means we'll get a total of 13. Now, why does this work? Because this first exponent means that we've got 7 of these negative 5s. And the next one means we've got 6 more negative 5s. So if I've got 7 negative 5s and 6 negative 5s, that means I've got a total of 13 negative 5s. So that's why the base doesn't change. I'm counting up how many negative 5s I have. So the negative 5 part doesn't change. That's our base. It stays the same. And how you know that that number isn't going to change is because we're dealing with the exponents. We're counting up how many items of some kind that we have. In this case, they were negative 5s. Sometimes they're x's, sometimes they're y's. But it doesn't change anything. Let's try another one. Let's take a look at B. In B, we have an a squared times b times a to the 13th, b to the 17th. So let's deal with these one at a time. Remember, we can only combine things if they have the same base. So I can only combine a's with a's. So if I have an a squared times an a to the 13th, remember the base stays the same, so it'll remain as an a, but I'll have 2 plus 13 for a total of 15 a's. Now I can do the same thing with the b's. I've got a b and then 17 more b's. Remember that first b means I do actually have one there. So when I combine them, the base stays the same. I'll still have only b's. I'll have 1 plus the 17 is a total of 18 b's. And that's my final answer. A to the 15th, b to the 18th. That's it. Let's take a look at C. In C, we have negative 7a cubed, b cubed, times 7a to the 19th, b. Okay, well, in this one, we're going to start by dealing with our numbers first. The negative 7 and the positive 7. Notice there are no exponents here. So we're just dealing with normal multiplication. So what is negative 7 times a positive 7? Well, that's a negative 49. Now I'm going back to exponents. I've got an a to the 3rd and an a to the 19th. Remember, the base will stay the same as an a. And then 3 plus 19 is a total of 22. Last part of this one is looking at the b's. We've got, let's see, a b to the 3rd and a b, which means there is a b there. So we've got 3 plus 1 more is a total of 4 b's. So b to the 4th, and we're all done. Our final answer is negative 49, a to the 22nd, b to the 4th. Last one here. Let's look at 12x to the 5th times negative x to the 6th times x to the 4th. Let's, just like before, deal with any numbers first that we have that are normal multiplication without any exponents, which is the 12 and this negative or a negative 1. Well, if we look at that first, a 12 times a negative or negative 1 there is just going to give me a negative 12. Then combining all the x's, we've got an x to the 5th an x to the 6th, and an x to the 4th. Remember, we're multiplying, the bases all match, so that it will stay the same, and we're just going to count up what we have. 5x's plus 6x's is a total of 11, plus 4 more is a total of 15x's. So we've got negative 12, x to the 15th, and that's our final answer. And again, you can see in all 4 of these that we just worked out is that you do end up with some pretty high exponents in these. And again, you have to start trusting yourself that you know what you're doing. That when you're multiplying, you're just counting up how many of everything you have. You're just adding everything up.
Now let's look at a special case. In this next case, we're going to look at when something is raised to the 0 power. So let's take a look. In this next example, what we've got is if we take anything and raise it to the 0 power, it's going to be just 1. The question is, why is that? Well, let's take a look. If we had, let's say, x to the 0, remember what's hidden out in front of any variable, if we have x to the 0, is a hidden 1. So what this means is that there are 0 x's. Well, if there are 0 x's, then the only thing you should have there is the 1 that was in front of it, which is a placeholder, so you just get the value 1. So let's do a couple of examples involving this special case of something raised to the 0 power. So let's start out with the first two. Let's kind of do these at the same time because they're similar yet very different. Notice these two, one has parentheses and one does not, and that actually does make a huge difference. So on the first one we have 4x and then raised to 0. And then in B, we have all of 4x with parentheses around it raised to 0 as well. Well, here's the difference. In B, our entire piece of 4x is raised to the 0 power. Because everything that we have will get raised to the 0 power, that entire piece turns into just the number 1. And that's it. Your answer is just 1. However, on part A, there are no parentheses, so the only thing raised to the 0 power is the x. So only that piece, the x to the 0, converts into a 1. It still has a 4 out in front. So you still need to take your 4 that was there times the 1 you just got from the x to the 0, which will actually give you the answer 4. Now let's try one last one. On this last one, we have x to the 0 plus y to the 0, and we're curious what that's going to equal. Well, we just did this. The x to the 0 is just going to be 1, but we also have a y to the 0. And the y to the 0 is also going to be just another 1. What are we supposed to do to these values? We're supposed to add them. Well, 1 plus 1 will give us a total of 2. And we're done. Okay, the kind of the last big idea that we want to look at is negative exponents. Well, negative exponents are going to happen. The question is, what do we do with them? Because we actually don't want to ever have answers that actually contain negative exponents. And what this rule says, let's look at the first one, is it says if you want to make a negative exponent positive, you can, but what you have to do is you have to drop that negative exponent from the top to the bottom of a fraction. So